Texus Fibre is a business that's been set up to create high-value materials out of wool. They're using technology to build on the unique characteristics inherent in wool to create textiles for industrial use. CEO Nick Davenport explains.
We're focusing on, initially, respiratory filtration. In other words, filtering the air that you breathe. We've identified a need in the world where there are millions of people who have a problem, and that problem is they don't have a choice when they step outside what to breathe. There's only the air, and the air is polluted, and it's hurting them and it's killing them. And so the World Health Organization in 2015 attributed over 5 million deaths annually to atmospheric air pollution. So it's a big problem. We started looking at this about 2010, thinking of the possibilities and contracting ag research to do it. For the last 4 or 5 years, we've been studying wool and what the differences are and what contributes to the differences in performance in our filters of various types, various treatments on the wool. And what we've decided is that the only way to get the best possible product is to control the genetic supply that we receive. For the last few years now, we have been actually manufacturing filter elements for regulated air filters in the workplace health and safety field, and those are being exported into South Africa, into Australia, and out of that technology, out of that learning and that qualification in our system, we're taking it to the next level. We started it off on a shoestring budget within another company and spun it out 3 years ago. At that point in time, we got support from GD1 investment fund, and then we went through an investment round last year, an angel investment round. And so we have about 20 investment partners, New Zealand Venture Investment Fund, Sparkbox, GD1, and a number of other investors, both in New Zealand and offshore, have come on behind us. This process here is roll stock of wool felted material as filter media, which has come off our plant in Christchurch. So we ship it up here to Auckland, where the plant is, to convert it, and it's cut here into individual filter pieces. I guess the special thing about this is the electrostatic performance of wool. So it has the amazing propensity to be a virtual dust magnet. So it's highly chargeable, positively chargeable. In fact, it's the most positively chargeable natural fibre that exists. And what that does, it enables it to capture the very, very fine, harmful particles, but without putting a lot of breathing resistance in the process. So we create a product which is very light and lofty and very easy to breathe through, but at the same time, very, very effective at capturing dust. And not only that, there are additional properties which just naturally exist in wool, which will remove other toxins and also make it naturally bacteriostatic. We card it in our lab scale carding machine. We take the carded bat, give it some slight pre-compression, and then run it between 2 plates which are perforated, and through those perforated holes run barbed needles, and those needles intertwine and lock together the fibres, and that's what gives us that densification and creates a needle-punched felt. So we can go from thick to thin. We'll take that into the line and we can make a very simple sample of a filter at an early stage, which we can then take and test immediately. This process here replicates what we can do on our production line. What this device does is it tells you what the breathing resistance is and the particle capture at the same time, and gives you a graphical representation. The particles we're filtering are the ones that are actually harmful to health. You can't see them. In actual fact, the size is between 0.2 and 0.4 of a micron, that tiny. So it's very, very important to be able to measure that, and that's why this device is very useful. This is a Pallas 1000 HEPA filter, so it's a high-efficiency particulate analysing machine, which lets us know the efficiency and the pressure drop. That's the particle capturing efficiency and the effort breathability in one device, but at all levels of particulates and all ranges, and it's a certified piece of equipment. They're part of our research and science program. And for example, the absorption of formaldehyde is a very, very topical subject in interiors and for people's lives. And we know that wool is a very good absorber of formaldehyde. How well that works in a face mask is what we're quantifying now. We started off manufacturing filter elements for health and safety in the workplace canisters. So these little things are little devices which fit into a respirator mask as a disposable canister. So that's where we learned our trade. So the next thing we've looked at is what we call the anti-pollution mask market for those people in environments that have difficulty breathing the air. So how are these results going, Sean?
We find ourselves matching the competitors in filtration efficiency, but we always beat them in the breathing effort.
Spot on, hitting the results.
Yes.
Good. What we've found by researching in the market is people have taken standard filter media out of air conditioning or other markets and just put it into masks. And it's created a number of problems, we believe, for the users because it's very hard to breathe through it. And that's where we saw the opportunity. So what we've done is we've designed our media to be the most easiest breathing. And what that means is the designer can completely redesign the mask to make the most breathable mask that's available. Now, these masks are not on the market yet. We are working with people at the moment who are designing masks, the next generation of masks, which are anticipated to be in the market next northern winter. The very small sector of respiratory filtration or protection of individuals outside of the workplace, we estimated around about $1.8 billion US, growing in excess of 5 to 7% annually. We're excited. It's a huge journey. We don't underestimate the tasks that we're taking on, but we are taking on the world with new products and taking on synthetic materials and replacing them with the functionality of a natural material. That won't be to everybody's liking, but it will be to some. And that's what makes us really excited, that opportunity and that chance to really make a difference. And if this works, it'll really make a difference to sheep farming in New Zealand.
This program was made with funding from New Zealand On Air.